Let's build up on our newly gained knowledge about asynchronous JavaScript code execution, and let's dive into network requests. And that means let's understand how we can utilize JavaScript to send HTTP requests kind of behind the scenes. So in this module, we'll have a look at what exactly I mean by that and why we would do that, and of course also how we do that. We'll then have a look at the two main ways we have for sending such requests, which would be using the XML HTTP request object and the fetch API, which is built into modern JavaScript. We'll have a look at how we transfer data between our clients, so between our browser side and the server side, and which different data formats we can use there, namely JSON data and form data. And we'll see examples for how we can get data with GET requests and post data with POST requests. And in case it's not clear what GET and POST means, I'll also explain that in this module. So what exactly is this module about? Well, of course, network requests, but what do I mean by that and why does this matter? Let's say we have our script and our web page, so the rendered HTML code, which we see in the browser, and, well, our script logic. And on the screen, so the rendered HTML code, we might have a form where the user can enter some data, and an unordered list where we output a list of posts which the user created, let's say. That could be a simple web page we're building. Now, we might be powering this with the help of JavaScript. Though I really want to emphasize that you could build such a page without any client-side JavaScript code. You could dynamically generate this HTML code, including the list of posts, which might be created dynamically, totally on the server. You could do all of that on the server with a language like PHP, for example, where you get data from a database on the server, and then you render different HTML content based on the page the user is visiting. But in addition to that, or as an alternative to that, we could utilize browser-side JavaScript to provide a better user experience maybe, where we avoid unnecessary page reloads. So we could have some JavaScript code that runs in the browser attached to this web page basically, where we, for example, gather the user input, where we maybe validate it to show the user an error message if the title of a post is missing or anything like that. And we're gathering all of that. We're maybe also managing clicks on posts in that list of posts to, for example, start a deletion process, anything like that. Now, besides that basic management of what we see on the screen, or besides giving us these basic tools of interacting with the user input, we might want to do more in client-side JavaScript. Let's say the user submits this form. The traditional way of sending this to the server would be to let the browser do the default work and send that off to a server where you then have code to handle it. Now with JavaScript, you learned that you can prevent the default, so that you can prevent this from happening, so that the form is not automatically sent to a server. And instead you can step in with JavaScript, for example, to validate it, but then also to store it on the server from inside JavaScript, to send a HTTP request to some backend, to some server, without reloading the page, which would happen if you let the browser do its default. And you might do the same for fetching posts, so that you fetch posts to update that list of posts without reloading the entire page. Because if we only fetched updated posts, we don't really need to re-render the entire page, right? And therefore, we might want to interact with our backend, which we need to have in any case, from inside JavaScript, instead of letting the browser do it with the default behaviors. Now, our backend here would typically be an API, and that stands for Application Programming Interface. That means it's a web server which exposes different so-called endpoints, different URLs to which we can send requests, and based on which request we send to which URL, different things will happen on the server. And it's the engineers working on that server-side logic, so the people writing the server-side code, that decide which endpoints exist. So which HTTP requests are supported, which URLs are offered. Now, as I said, traditionally, the page and the browser might have communicated with that server directly, but that's not what we want here, because that would mean that our server always needs to return a brand new HTML page, and therefore the page would need to reload, would need to be re-rendered. That could lead to page flickering, and in general, it might not offer the best possible user experience. Instead, what we want to do is we want to reach out to these different endpoints which I described, where we, for example, might support on the server side a post request to the server domain.com/posts and a get request to the same domain/posts, where we might support certain pieces of data that can be attached to the incoming post request. And I'll come back to post and get in a second. And where therefore this server doesn't really want a default request sent by the browser, but needs specific requests targeting these specific endpoints. And that's what we can do with the help of JavaScript, with some behind-the-scenes communication, as I'd like to call it. Behind the scenes because it happens without the page reloading, without us refreshing the web page. Instead, we'll utilize JavaScript to send requests that are correctly configured and hold all the data the server wants to these individual endpoints. So now that we have this big picture, let's have a closer look at this HTTP request thing. How does this actually work? Well, we have our script, our client side, so the code that runs in the browser, and we have our server, the backend, the server side. Now, we can also name the client side as frontend because it's what the user sees, what the user works with, and that is detached from that backend. The backend, so our server, could run on a totally different domain, a totally different server than our frontend. So we might be serving the HTML page and the JavaScript, which is responsible for what the user sees, on mypage.com, whereas the server-side logic might be hosted on a totally different server, let's say on mybackend.com. Still, these two pieces or these two ends can communicate, and the job on the client side is to get the user input, validate it, and then to send it off to the server, because the job on the server side is to store and retrieve it in a database typically, and the database would run on yet another server. It's important to understand at this point that you don't directly connect your client-side JavaScript code to a database for security reasons, because you would expose your database credentials in the client-side code, which you don't want to do, but instead you talk to a web server, and that web server might then talk to a database server. Of course, using a database is totally optional, but of course, often the server side will use one to persistently store data and then get it from the database. Now, the communication between the client side and the server happens with the help of HTTP requests and responses. And these requests and responses have to be configured and set up in a certain way, following a certain structure. When you're sending a request to the server, it needs to know the address. So it needs to know the URL, made up of the domain and the path. The path is the part after the domain. So mypage.com/posts, mypage.com would be the domain, /posts would be the path. In addition, each HTTP request has a HTTP method that is assigned to it. Now you have a couple of available HTTP methods. You have, for example, get, post, patch, put, and delete. These methods describe what you want to do, though I will say it's totally up to the server to decide for which method URL combination the server wants to do what. So with the method, you don't tell the server what to do. The server just exposes different endpoints and, for example, might support a post request to /posts, whereas it maybe might not support a patch request to /posts. But again, it's up to the people writing the server-side code to decide which HTTP method URL combinations are supported. Typically, of course, you go for combinations that make sense logically, because there the logic is that GET requests typically are there to get data, POST requests are there to create data on the server, or create data on the server which might be stored in a database there. Patch and put are there to update data, patch in the sense of updating the existing data, put in the sense of overwriting it, and delete, as you can guess, is there to delete data. That's what you commonly use, but again, it's the server side that decides which HTTP method URL combinations are supported on the client side, you then can send requests to these combinations. If you use a combination that is not supported by the server side, you'll simply get a HTTP error as a response. Now, other parts of a HTTP request are potential headers, that is extra metadata which can be attached to HTTP requests. And some requests, for example a post request, also hold a request body or extra data which is attached to the request. As you can imagine, if we're getting a list of posts, there is no data we could attach. We want a list of posts and we're done. If you want to add a post, if you want to create a brand new post, that of course is different. Then you want to attach the data that is required for the post creation, like the title and the content, to the request you're sending. So that's the idea here. Now that data then can be sent in different formats, and again it's the server that tells you which formats it expects or supports. The most common format is JSON data, which I'll dive into in more details in a second, but we also have form data, which is supported in JavaScript and which is fairly popular. And you could also send binary files or other formats, but again, it's up to the server to decide which data format is supported for which HTTP method URL combination. Now, that is all the theory. If that is all brand new to you, attached you find a couple of resources that allow you to dig deeper into how the web works, into HTTP requests and HTTP methods. I will now move on, and now we'll have a look at how we can actually send HTTP requests to a server from inside JavaScript. Now for this module, we again have a little starting project which you find attached. It's a HTML file with some content in there, some styling, and an empty script file which is already getting imported here. And that's of course the script file where we will add our logic. If you load the HTML file, you'll get this output on the screen. As you see, this is a project which will allow us to send data and to also get data. And now the tricky thing is, we need a server. The browser-side JavaScript is not enough. Now we could write our own server with the help of JavaScript and Node.js. Node.js is a JavaScript runtime outside of the browser, which basically enables you to execute JavaScript anywhere, and it's a popular solution for writing server-side code. Actually, later down in the course, I'll have a module where I introduce you to Node.js, so that might be interesting. For the moment, in order to focus just on the browser side, we'll use a dummy API, a dummy web service we can talk to. And that's this page, jsonplaceholder.typeicode.com. You'll find a link to that attached. This basically is a page that gives us a dummy web service, a dummy API we can send different requests to. Any data we send to it, of course, is not permanently stored there. It's just a dummy API which fakes to store the data, but it's great for getting started with all of that. Now, you'll learn how to use it here on this page. You even get working JavaScript code here, though we'll not start with this code here. And therefore, it is super simple and a great place to start practicing. Now, if you scroll down a bit on the starting page, you'll see the supported routes or endpoints, you could say. And there you see various HTTP method URL combinations are supported. Now, these are just the paths, but they're always appended to this domain, building a URL therefore. And it's a GET request to /posts, which, for example, is supported, or a POST request to /posts, or a delete request to /posts and then some specific post ID. And we'll use this in this module. We'll see various different HTTP methods in action, and this just shows you which kind of requests this fake API accepts. If you would try to send a different request, let's say a request with the method of post to a URL or a path which is not listed here, then you would get an error. So that's what's supported. Now let's see how we use it. Now we'll work with this /posts endpoint, and that's the first important thing. If we click on that, you'll see this data. This is actually JSON data, and I'll come back to that in a second. What we have here in the URL is the domain, so jsonplaceholder.typeicode.com, and then /posts would be the path. And what we send here by just entering it like this in the browser is a GET request, because the browser, if you enter a URL, sends a GET request. Now, of course, we don't want to fetch data like this. We want to fetch it from inside JavaScript. So that's what we'll do. We now just found out that we can send a request to this URL in the end. So that's a great starting point. And with that back in app.js, let's get started and let's send our first HTTP request, starting with the XML HTTP request object. And later I'll come back to that and which alternatives you have and when you want to use which. So how can you send a HTTP request then? It all starts with creating a new XML HTTP request object. And I'll name it XHR, that's the name of my constant. And with new XML HTTP request, you create such an object. So that's the starting point. This object will allow you to send HTTP requests. It is built into the browser, and all browsers support this object. It has a really good browser support. Now, to send a request or to get started, we need to configure the request. And the first step for that is to use our object, so XHR, this constant which holds the object, and call the open method there. Now, open sounds like it opens a connection or anything like that. Actually, it does not do that. By calling open alone, no network activity will be started. It's just the first step towards configuring the request. Open takes at least 2 arguments here, and the first one describes the HTTP method you want to use. Now here, that's get, because we want to send a get request. So you pass a string with the value get as a first argument to open to send a get request. And as you saw, if we send a request to this URL, I said the browser would automatically send a get request. We get back this data, and this actually looks like a list of posts we could work with. So let's send a get request. Now we need an additional argument here, and that's the URL to which we want to send that request. So here, that's another string, and here you can paste in that URL to which the request should be sent. So in this case, the URL we just used in the browser. With that, we basically configured the request. We informed the XHR object which kind of request we want to send to which address. Now, in order to send it, we have to call XHR send. This will send the request. Now, if we save that and we go back to our page and we reload, did something happen? Well, we can find out in the developer tools by going to the network tab there. If you go there, you'll see any network requests that are sent. Now, if you clear that and you reload, you see here we got a bunch of requests being sent. And if we have a look at the requests that were sent, we see the index.html file. That makes sense because that was loaded. We see the CSS file. Also makes sense. We need that. That was loaded as part of the HTML file. Same for app.js. This script also needed to be loaded. But then we have this request here at the bottom. And this was not to a file, but this was to this URL we entered. And if we click on that, we can inspect this request. And here we actually see, if I shrink this a little bit, here we see the data that was returned by the request, which in this case is a list of dummy post data. If we click on headers, we see the configuration of the request. We see it was a GET request to this URL. We see the headers that were attached to the response. These are attached by the server when it sends back a response. And we also have the request headers. These are the headers that were attached to our request. Now, of course, we didn't specifically add our own headers, but the browser attaches some default headers like the user agent, for example. So the request indeed was sent, and we got back some data. Now we just need to find out how to use that data, and for that we first of all have to understand the data format. Now, the format of the data is really important. You exchange data between your client side and the server side in a certain format. And technically, there are no restrictions. You can send plain text, you can send HTML markup, you can send XML markup, you can send CSV files, or as you typically do, you use this data format which is called JSON. JSON looks like this. If you click on response, you see the raw response, and JSON stands for JavaScript Object Notation. Indeed, as you can tell, this looks a lot like JavaScript objects, in an array, and JSON is derived from JavaScript data types, from arrays and objects in JavaScript to be precise. It's almost the same, but there are a couple of differences. In JSON, you can only store data. You can't have methods in there. You can't send functions to a server. In addition, your property names have to be wrapped between double quotes. It must be double quotes and it has to be wrapped. So user ID without quotes would not be allowed. It also would not be allowed with single quotes. You need double quotes. Now, as values, you can use numbers, booleans, strings, other objects, or arrays. That's supported. Null is also allowed. And then this is basically it. This is how the data looks like. You can also have nested objects and nested arrays. This is all allowed. And this is how the data is transferred between the two ends. So here we received data in this JSON format. It would now be nice to parse that from the response so that we can actually output it on the page at a later point of time. Now for that, let's see, how can we get to the response here when we send a request? We have to wait for the load event, which is fired automatically once the data is loaded, so once the request completed. And we do so by setting up an event listener, basically. However, XHR does not always support add event listener. Older browsers don't support that. I think Internet Explorer does not support it at all. And therefore, the more common way of listening to that is to assign a function to the event handler, to xhr.onLoad. To this property, you assign a function, and you saw this syntax in the events module where I showed you that this is an alternative to adding event listeners. Here we should use that because add event listener is not broadly supported. And here we can connect a function written in any syntax you want. Here I'm using the function expression syntax that handles the incoming response. Now we don't receive the response as an argument here, however. Instead, we can extract it on the xhr.response key. Now let's console log xhr response here and see if that works. If we tweak the code like this and we then reload here, this looks pretty good. Was very fast because it's a fast API, but this looks pretty decent to me. This is the output JSON data which was fetched from the server. And that's important. This is not a native JavaScript array with which we could work. It's JSON data. If you would try to store that list of posts from XHR response, you would not be able to, for example, push a new element there. If you try to do that and you reload, you see you get an error because XHR response gives you JSON data, not an array you can use like that. In order to use it, you have to convert the JSON data to JavaScript types, to JavaScript arrays and objects and so on. And JavaScript has a built-in helper that helps you with that. It has a built-in JSON constructor function or class, which has a couple of static helper methods, parse and stringify. Stringify helps you convert JavaScript code or JavaScript objects and arrays to JSON data. And parse helps you convert JSON data back to JavaScript. So here we can parse the XHR response. And now if we console log list of posts, we should have a JavaScript array with which we could work. So if we now save that and we reload, this looks better. This now really is a JavaScript array. And you see, for example, the double quotes around the property names are gone. This is now really JavaScript data with which we can work. Now important, you can manually parse it like this, and I wanted to show you this JSON helper object. Actually, there is a little convenience built into the XML HTTP request object. If you set XHR response type here to JSON, and it has to be exactly this term, then this will automatically be parsed for you. So then if you would duplicate this line, you could store the response without manually parsing it because it will be parsed behind the scenes for you if you add this extra configuration. So now with this code, if I reload, we'll have the same result as with the manual parsing. It's important to be aware of that JSON parse helper functionality though, because often you will need that. Not always you can pre-configure it like this. So now we got this list of posts. Outputting it in the console is nice. How can we output it in the index.html file? Well, there we got the unordered list with a class of posts. And there I want to output it. And I get this template, which holds a list item, which I want to use for outputting it. Now, to do that, we can add a new constant here, list element, for example, and get access to it with document query selector, and then select by the posts class, because we'll only have one element with that class on the page, and get access to our template here. And we might want to add an ID to that. We could also select it by just the template tag, but here I'll give it an ID of single post. That's totally up to you though. And now we can select this template, so post template, with document get element by ID, single post. And now we want to add a couple of posts for this list of posts to our unordered list, or maybe turn all these posts here, all these posts into list elements. And to do that, we can loop through our list of posts. So for, and now we'll have a problem. Can we loop through our list of posts here? We can't, because they're only available here inside of this anonymous function. This is when the response is there. This happens asynchronously, and as you learned, JavaScript will not block code execution. It will continue with these lines, even though the response might not be there yet. And therefore, actually, we should do our looping logic here inside of this function, because that's the only place where we have the guarantee that the posts are available. Hence, I will now also move that up there, my two selections, and now loop through my posts with const post of list of posts here inside of that anonymous function. Now the goal is to replicate the template for every post and add it to the list element here. For that, we can get access to our post element with document import node, and then we want to import the post template.content and pass through here to make a deep clone. And on this post element, I now want to select the h2 tag, which we have in there. We also have a paragraph in there thereafter. And then here, set the text content equal to post dot. And now if we have a look, we see that every post which we fetched has a title property and then a body property with some dummy text. So here I want to set this equal to title and maybe to uppercase to convert it all to uppercase characters. And also post L query selector for the paragraph. And there I want to set text content equal to post.body, just like that. Thereafter, we can reach out to the list element and then append our post element like this. If we do that and we save this, let's reload and see whether that works. And that looks quite good. We rendered a bunch of posts here in our list of posts. Quite a lot of them, but that's okay. So this is now how we can also utilize the data we fetched and output it, not just in JavaScript, but also on the screen. Of course, it's nice that we're able to get data, but often we also want to send data. For example, here we have our form, and when I click add here, right now the form gets submitted and hence the page gets reloaded because the browser does its default thing and sends a request automatically to some server, the same server where the HTML page is hosted on. And that's not the behavior I want. I want to send a request to this JSON placeholder page, because that, if we click on guide, does not just support getting resources or listing all resources, it also allows us to create a resource by sending a post request. And therefore, that's what I want to do here. Now, for that, we should restructure our code here a little bit. We could, of course, also improve it a lot by, for example, using object-oriented code. I'll just tweak it a little bit by wrapping this HTTP request sending logic into a separate reusable function. I'll create a function, send HTTP request, for example, which wants a method and a URL, let's say, for now. And in there, we have all that code. So let's cut it and move it in there. And now replace get here with method, so with the value we receive here, and the URL here with the URL parameter, so that this is flexible. Response type will always be JSON here, so I don't need to tweak that or don't need to make that flexible here at this point. And now in onload, I also don't want to have the logic, what I do with the response, hard-coded in there. Instead, how about promisifying all of that? That would be easy. We can create a promise here with new promise, as you learned it, pass that function to the promise constructor, where we get resolve and reject, as you learned it, and then actually move all that code here into this constructor, or into this function we pass to the constructor. And now here, when we're done, I want to call resolve and simply forward xhr.response, because that's our response data. Thereafter, we can return the promise here. And now below that, we can call send HTTP request to have a reusable function. We'll have to remove that code from onload, of course. We'll do that in a second. First of all, let's start by adding a new function, fetch posts. And in there, I will send my HTTP request, a GET request to this URL, which I cut. And then with the response data in this function, which I pass to my then method, and we could use async await instead, of course, I'll use that code, which I had in onload before, and move that into my then block here. Now again, the alternative would be to use async await, add async in front of the function. Then we would get our response data here by awaiting for the response of send HTTP request. We would remove then and instead add a semicolon and remove that extra function here, which we now don't need anymore. Remove this closing parentheses here as well. And now we would have this code. So that is how we can do it with async await for this response data here. And now we can use response data here instead. So store that in list of posts, go through all the list of posts, and if we then call fetch posts here, we should still be able to, well, fetch the post whenever we reload our page. Yeah, seems to work. Now let's make sure we can also send a post request, so a request that adds data on the server. For that here, I'll add a new function, async function create post, or however you want to name it. And there, let's say I expect to get a title and the content of the post. And then here I'll have the post ID, which I'll generate with moth random, just a random number. And now overall I have the post object here, you could say, where we have a title of title, where we have a body, because our API here actually wants a body field. It wants that we send it a title, a body field, and a user ID. So actually this here should be user ID, sorry. So user ID, then title, body should be the content argument we're getting, and then user ID, and make sure you write it exactly as the API expects it, so with a capital I. That can be equal to a hard-coded value or to the user ID I set up there. So this could now be the post data we send to the server. The question just is, how do we now send this? Well, we can reuse our send HTTP request function, which we created up here. And now the URL is actually the same as before. The server we're talking to supports this URL. You can see that in the examples here as well. This is a URL we can send a post request to. But the method is a different one. The method now is post. By the way, it does not matter if this is all uppercase or if you write it like this. Convention is to use all uppercase, but it's not required technically. The URL is the same URL as before. And now we will actually need to enhance this method, because now we need to be able to also add a body to the request. For a GET request, you don't need that. You just want to get data, so you don't append any extra data to the outgoing request. For a POST request, where you want to create data on the server, you need to add the data you want to create to the outgoing request. And to do that, we need to tweak our function, the send HTTP request function, to also expect a data argument, or to support it at least. By default, this can be null, or it actually is undefined by default anyways if we don't pass it, so we don't need to set this up. And now we can append this to the outgoing request. To append data to the outgoing request, you go to the send method and pass your data to send. However, not just like this, but it needs to be JSON data. So we should call JSON stringify and pass data to JSON stringify and then pass the result of this stringify call to send. So this will now add this extra data here. With that, we can call create post here after fetching the posts and create a dummy post with a dummy post as content maybe and just dummy as a title. And now we just have to make sure that in create post, we use that post object which we created and add that to the request we're sending. So here as the third argument which we just added to the send HTTP request method, we can add post. And inside of the send HTTP request method, this will be converted to JSON and attached to the outgoing request. With that, if we save that and we reload our page here, we don't get an error. Let's check the network tab. And there we see this extra request down there. Now the status codes here, by the way, signal whether it worked or not. 200-ish status codes mean that the request succeeded. 201 means that it succeeded and a resource was created on the server. And therefore this is looking good. Though keep in mind, no actual resources are getting created here. We're talking to a dummy API which just fakes that it does something. Nonetheless, if we inspect this, we see a response. This could be an ID, which the server automatically generated for our sent data. And on the headers tab, we see our URL, our HTTP method. And if we scroll to the very bottom, we see the request payload. And that's the data which was appended. And here we see that indeed is the data we generated. So this is how we can send a request with JSON data to an API. It's as easy as that. Now let's tweak our little project here a little bit, and let's make sure we actually send the data which the user entered, and we also only send it when we click add, or we fetch it when we click fetch. So sending requests generally works. Now let's link it to our UI, because that's a bit more realistic. And for that, we also need access to the form and to that fetch posts button. The form here is in the section with the ID new post, and the button for fetching posts is in the available posts section. So we can use that to select our elements, form, by using document, query, selector, and then that would be, what did I say? New post is the ID, and then there the form element, and the fetch button, that would be document, query, selector, and then there we have the section with the ID available posts, and there it's the first button which we find. So here ID available posts, and then the first button. Now we have access to these two elements. Now for fetching, we can scroll down here, and we can reach out to our fetch button and add an event listener here, where upon a click, I'll use an anonymous function. Doesn't matter if it's an arrow function or created with the function keyword, where we call fetch posts. Of course, we can also shorten this and just point at fetch posts like this without parentheses. And for the form, I want to add an event listener for the submit event. And then here we get the event object where I want to call prevent default so that the browser does not submit the form. And now we could also validate the form here if we wanted to. We could validate the user input. I'll not do that here. It would just be about fetching the inputs, checking the value the user entered, and then maybe presenting an error. Again, not something I want to focus on in this module. Instead, I want to get my input from the field with the ID title and from the field with the ID content. So to get that access, I will get my entered title by reaching out to event current target, which is the form, query selector title, that should give me the title input, and then dot value is what I'm interested in. And for the entered content, I do the same for the field with the content ID. And now here I can call create post and forward the entered title and the entered content here. With that, if we save that, let's reload. And now we don't start with any posts here. If I click fetch posts, however, they are fetched. And now to add one new post, let's try it. If I click add here, you see that request is sent and it contains the data we just entered. So now we connected these two requests to our UI. Let's now mix it up and also see how we can send a delete request. We're not restricted to get and post requests. There are more HTTP methods, and it just depends on the API you're working, which kind of requests you can send. And here, this JSON placeholder dummy API also supports deleting a resource. Again, it's just a fake, as it says here, but we can send a delete request to this URL. And now please note that this URL is a little bit different. Here it includes the ID of a concrete post to fake that we delete that post. Now if we have a look at our list, we do have a delete button on every post. Now we just have to make sure that the ID, which is part of every response, is kind of mapped to its element so that we can then find out on which element we clicked the delete button to send the right delete request. For that, in the place where we output all posts, here, when we render the post elements, I actually also want to add an ID property here. For that, I want to go to my post element there, and then use query selector li to select the li element itself, and set the ID on that to post.id, so that we have that ID assigned to every list item element. If I now reload this page and click fetch posts here, and we go to the elements tab, you see every list item has its ID as an attribute added. Now we can use that to then make that delete button work. For that, we should add a listener to the delete button. And now we could add a listener to each delete button, or we use event delegation, which we learned about in the events module, to only use one listener on the list and then find out which list item or which button in which list item was clicked. For that, we need access to the overall list here. Post list with document query selector unordered list, because I only have one unordered list on this page. And here on post list, we can add an event listener for a click and then accept the event object and do something. Now, of course, I don't want to delete anything just because a click happened anywhere on that list. Instead, we now need to find out which item was clicked and if it was the button that was clicked there and not just anything else in the item. To check that, we can reach out to event.target. We can then have a look at the tag name property. Now, if that is button, all uppercase, then I know I clicked on a button. Well, let's first of all check if that works by logging clicked on button like this. If I now save that, reload, fetch the posts. If I click anywhere, nothing happens. If I click on delete, we see clicked on button. Now we need to find out to which list item this belongs. And for that, we get the post ID by using event.target.closest to get the closest list item. We know we clicked on a button. Now I'm interested in the closest list item. And then on this list item, we have the ID. So now this should give us the ID of the post we clicked on, or on which posts we delete button we clicked on. So if we save that and reload, if I fetch posts and I click on delete, here I print 1, here I print 3, here I print 5, so that seems to work. Now we can work on the actual delete request. For that, let's again send a HTTP request here, this time of type delete. And for the URL, I'll now use backticks because I want to inject something into the URL, so to say. The general URL is the same as before, so we can copy that. But then we need to add a new segment to the path, so a new slash, and then dynamically injected the post ID, so that we add this at the end of the path, because that's what the API wants. The API wants that the ID is part of the URL, the ID of the post, which should be fake deleted. Well, and with that, we should be good. Now a delete request should be sent when we click on delete. So if I click delete here and we check the network tab, we see here this request was sent. It's a delete request to this URL, and that's all right. The API doesn't seem to reply back with anything. It doesn't say so on the guide here either. And therefore, that's it. Now, of course, you could delete the element from the UI. That's something you absolutely can implement. It's not related to HTTP requests though, and therefore I'll save the time here, not update the UI, and instead move on to other nice things you can do with HTTP requests. Thus far, we always assumed that everything works, but in reality, of course, you'll also have HTTP requests that fail. And handling such errors is also important. Now, HTTP requests can fail for many reasons, because the internet connection is bad, because the server is down, because you send invalid data. There are many ways HTTP request can fail. Now, to be informed about a failing request, we have to add another listener to our XML HTTP request object, and that's the onError listener or handler. This will trigger whenever we, have an error when we send the HTTP request. Now let's see what we get here, and for that let's console log XHR response in the error case, and let's also console log something else, and that's the XHR status. This gives us the status code we got back. Now to simulate an error, we can, for example, go to our GET request and send this to an invalid URL by basically cutting off the TS of the path, and therefore we have a path which is not supported by the server. If we do so and we now reload, let's open the console here, and now click Fetch Posts, and you see here I'm getting an error. This is getting logged from line 25 of my script. So from the send request in the end, not from line 21 or something like that. And here we also got another error from line 37. That's just indicating that we failed to loop through all the posts. If we have a look at the network tab, we also see there we got a 404 response back. What we don't see is our error handler doing its job here though. And that's indeed important to understand. The error handler here does not kick in for HTTP requests that are technically successful, where we just have a server-side error, so where we just get back a non-200 status code. This error function instead will kick in if you, for example, have a network error. So if the request fails to be sent or does timeout or anything like that, if you have a request that leaves your page successfully and you get back a response, even if that response indicates that something is wrong on the server side, for example, that the path wasn't found there, then you're not making it into onError, but instead to onload, because technically you have a correct request and response. So what you should do is you should check if XHR status, if that is, let's say, greater or equal than 200, and at the same time smaller than 300, which indicates a success case. In this case, I want to resolve. Else, in the other cases, I know something went wrong, and then we can reject this, and for example, reject with a new error object here, where we say something went wrong. Like that. Here in the onError handler, I of course also want to do that. I want to reject with a new error. Failed to send request, but this will simply happen at a different time. This will happen if we technically fail to send a request. Now we have proper handling for server-side errors as well by checking the status code here in onload. And therefore now if we try this again and we click Fetch Posts, now you see something went wrong, which is my own custom error message. And now we can of course use the normal ways of handling this on promises with catch blocks, or when using async await with the help of try catch to make sure we don't continue if we have a problematic promise here. So here we could then wrap this all into try and catch an error here, and then maybe show the error message to the user. And now with that, we would properly handle that error. If I click fetch posts, now we just get that error message here instead of that broken script. The key takeaway here really is that you don't make it into on error because the server reports back a non-success status code, but that you instead stay in on load if that happens, and you only make it into on error if the request fails for different reasons. If you have no internet connection, for example, then this would trigger. Otherwise, you reach on load. And therefore, in on load, you should also handle non-success status codes as we're doing it here. So we got started with HTTP requests with this XML HTTP request object. By the way, you might be wondering where the name is coming from. In the past, actually quite some time ago, this was basically introduced so that we could fetch XML data behind the scenes. Nowadays, of course, it's more common to use JSON data. The name, however, still is the same. Now, there is more you can do with it, more you can configure, and you can dive deeper into XML HTTP request, as you can actually dive deeper into almost all things you can work with in JavaScript. Attached, you therefore find some resources that do allow you to dive deeper in case you're interested. Now, however, I want to have a look at a more modern alternative, which was added to browsers a few years ago and which actually is not supported in all browsers. Especially older browsers, Internet Explorer, don't support that new API which you can use. And that new API I'm talking about is the Fetch API. Now, to use it, let me comment out all of that here inside of my promise construction function, so to say. Let's keep the promise itself, however. So all the XML HTTP request logic in there is commented out, and let's instead use that new API which we have for sending HTTP requests. It was invented to be more modern, to be less clunky with these strange event handlers there, which is really not modern JavaScript at all. That's why this new API was introduced, and that new API is commonly called the Fetch API. Now, it is called such because it all works around one key function, the fetch function. And this is built into browsers. It's exposed in JavaScript just like that. You don't have to call it as a method on any object or anything like that. It's a globally available function in modern JavaScript. As I said, not in old browsers though. More on browser support in the, well, browser support module of this course. So how do you use fetch? In its simplest form, fetch just takes a URL. So we can pass URL, which should be a string, to fetch. Then it will send a GET request. So if you just pass a URL to fetch, it will send a GET request to that URL. Now, fetch by default is promise-based. So that's the first native promise API we see in this course. We don't have to promisify it ourselves. It uses promises on its own. That means we can actually remove our promise wrapper here. We don't need to build our own promise. Instead, we can just return the result of fetch, which, as I just said, is a promise. So we can fetch a URL and then return the result, which is a promise that helps us work with the, well, response. Now, let's see how that works before we then fine-tune it for the different kinds of requests. And let's get started with fetching posts, where I call send HTTP request. And therefore, we try to send a request to this URL, which we should now fix, by the way, with the help of the Fetch API. Now, if we try that and we reload and I click fetch posts, you'll see that I actually get an error. I get this alert here. Now, this can be a bit deceiving. To see the actual problem, let's temporarily remove try catch here in fetch posts so that we don't try this block and catch any errors. Like that. And let's try again. Let's reload and click fetch posts. And now we see I get this strange error. List of posts is not iterable. Okay, so what's going on here? What's failing? Somehow we don't have list of posts. So somehow we don't get the response data when we call send HTTP request. Now in send HTTP request, however, in this function, I do return the result of fetch, sending a request to that URL. Now let's check the network tab. There we see posts were indeed fetched, so that seems to work. So what's wrong then? What's happening? Well, the problem is, or one difference is, unlike our XML HTTP request approach here, fetch does not give us the parsed response as we had it available here with XHR response, but instead it gives us a streamed response, which means basically that the response object we get here does not hold the body, the response body, in a way that would be ready to be used. Instead, what you have to do, we can do that here inside of the send HTTP request function. Instead here, you get your response object, and there you have access to a response JSON method. And you can return the result of this because that actually yields a new promise, as you see. Now JSON, when you call it on the response object, which the fetch API gives you, will parse the body of the response and transform it from JSON to JavaScript objects and arrays. But it actually does not just parse that, so it's not just a replacement for JSON.parse, it also turns the streamed response body, which you have in the response object, into a snapshot, so to say, with which you can work. So long story short, you need to call response.json to convert your response body, the streamed, unparsed response body, into a snapshot parsed body. So now with that, the overall send HTTP request method will yield a promise which will eventually return that parsed response data. Response JSON is important for that. Besides response JSON, you also have response text, for example, to return plain text, so that will then just do the conversion from streamed to snapshot, or response blob if you would be downloading a file that would give you access to the file. Here, however, we got JSON data, so we need to return that. So now with that, if we save that and we reload and I click fetch posts, now we render the posts again. So now the other logic works as before, and just as before, we get the parsed data, the parsed response. But here important, we need that extra step because it's not just JSON data, but also streamed data, which we need to turn into a snapshot, so to say. And all of that is done by that JSON method on the response object. Okay, so we get that, we can get our posts. Now let's make sure we can also create a new post. In order to be able to create a post, we need to make sure that this function here can succeed. And for that, we need to make sure that we use the HTTP method in the fetch API and also the data, the body that should be appended to the outgoing request. Right now, we always just send a fetch request to a URL, and therefore we always send a GET request. Now, just as with XML HTTP request, we can configure the outgoing request. However, unlike XML HTTP request, you don't pass the request method here directly as an argument to the fetch function here. Instead, you can pass a second parameter here, a second argument, which should be an object where you can configure the request. And there you got a couple of keys you can set, as you see. A lot of them are pretty niche and rarely needed, but method is one of the more important ones. Method should be set to a string, and by default it's set to get, so you never need to set this, but you can. But you always need to set it to post, put, patch, delete, and so on if you plan on sending such a request. So here I'll set it to method, pointing at the parameter I'm getting here in send HTTP request and forwarding my parameter value as a value to this key value pair here. So that will set the method. Now you can also set the body, and that has to be set to JSON data. So not just to data like this, data would be my third argument here, but instead to data converted to JSON, which we can do with JSON stringify around data. If we now do that and we reload and try to enter a new post, does this work? Let's see if it works if I now click add. So if I clicked add, we go to the network tab, we see this is the post request we just sent, status code 201, and indeed here, that's the body we appended. So here we can see, yes, this worked, this request successfully was sent. Now with help of the fetch API. Now let's also check if deleting works. If I fetch posts and I click delete, let's say on the second post, then a request is sent here to the post with ID 2. It's a delete request, has a 200 code, so that seems to work. Now before we have a look at how we handle errors here, let's have a look at how we can add headers to HTTP requests, not just with the fetch API, but also with XML HTTP request. Headers can be important. Now, thus far we haven't really needed them, but for some APIs you need to describe which type of data you're sending, for example. Or other APIs might need some extra authentication data. And headers are basically metadata you can attach to outgoing requests. If you inspect requests, you see there are some default headers added by the browser, and the response also has headers set by the server. Now we can add more headers to the outgoing request. And we do that here on fetch by adding a new key to that configuration object, which is the headers key. This takes a JavaScript object where every header which you want to add is a key value pair. Now, the types of headers you can add are generally standardized. There are some default headers which are typically used, but you can also add any arbitrary header you're coming up with. So you're really flexible there. Of course, a header makes only sense to be added if the server expects it and does something with it. Otherwise, you can add it, but it won't have much effect. Now, a header which is often added, even though it's technically not required here for this API, is the content-type header, typically written like this. Content type has a value, so that's the key name here, has to be in quotes because of the special dash character here. The value for that header then is application/JSON. That's one of the typical headers you add to outgoing requests which carry JSON data. This tells the server, hey, my request has JSON data. Now our dummy server here, JSON placeholder, does not care because it always just expects JSON data. Other APIs might care, and then this is how you could add your header. You can of course add more than one header by adding more than one key value pair here. Now let's see if that works. If I add this header here, if I reload and I fetch my data, we see that on this fetch request, if we scroll down to our request headers, here is the content type application JSON header we just added. So this is how you can add headers with the fetch API. On XML HTTP request, it would have worked as well. There you have the set request header method, where the first argument is the header name, content type, and the second argument is the value for that header, application/JSON. And you can add multiple headers by calling this method multiple times. Important, once a header is added with this method, you can't delete it. Now here I'll comment this out, of course, because I don't need the XML HTTP request anymore, but that is how you could have added headers there, and this is how you add it with the fetch API. So we see that the fetch API thus far is pretty easy to use, and it uses promises by default. And actually it only works with promises. So it looks a lot better than XML HTTP request. Now one downside of it, of the fetch API, could be that it doesn't support older browsers, but as you will learn in the browser support module, you might be able to work around that. A bigger problem, or a bigger annoyance at least, can be seen when we have a look at error handling. So let's see what happens there. Again, I'll break my get URL here by simply changing this to a URL which does not exist on the server we're sending the request to. And let's see what happens in that case. If I reload, click fetch posts, well, at some point we get an error that we can't use the response data. So of course we work with promises there. So since this returns a promise, we could use try catch to wrap this all into our, well, try catch block and do our error handling. Or if we didn't use async await, we could use the catch method in our promise chain. Now, the problem with that just like with the XML HTTP request, that request that technically succeeded, so where we don't have a technical issue, but maybe just a 400 or 500 status code sent back by the server, will not trigger a traditional error. So if I would try to add some first error handling here in my send HTTP request function, then I could add a catch method here in my promise chain, which I return. And keep in mind that this promise chain itself also returns a promise. That's how promises work. So here I could then catch any error we might be getting, and we could handle it here, store it in some internal log, and then maybe just throw a new error object where I say something went wrong, or maybe we also provide more information than that. The problem is we'll never make it into this catch block for the error we currently have. If I fetch posts again, you see this is coming from a different place. We got no log coming from line 44. We got the line 56 here. So we don't make it into the catch block, and the reason is the same as with XML HTTP request. Only technical issues like network connectivity issues would lead us to go into that catch block. Instead, we're here in the then block. Good thing is, just as with XML HTTP request, we can check the response status and find out if we have an error here. So if response status is greater or equal than 200 and response status is smaller than 300, then we have a success case, and then I want to return response JSON. Else, I know we have an error. So else I can throw a new error here. Something went wrong, server side. Anything like that. So if I save that and I now reload, if I fetch my posts, now we get that correct output. But still we have a problem here. What if we want to look into the body of our response? Because often, for server-side errors, the server might attach extra information to the response body. So it's not just about the status code. Even in the error case, we get back a valid response with a response body, and we might want to parse that response body to get the data that the server might have added. Now, in the XML HTTP request world, that would have been easy. Here in this else case, if we got an error, we could still access xhr.response. That would be possible here in the XML HTTP request world. Unfortunately, that's not the case in the Fetch API world. Remember, the body is streamed. So at this point of time, we have no direct access to the body. We first of all need to call response JSON in the error case as well. So we always need to call that in order to get our data. Now, of course, you could think, well, then I just add an extra step here, return response JSON here, no matter if it's an error or not, and then I check my response status code in the next then block where I have access to the body data. The problem just is, here we get the data, but we don't have access to the response object anymore. We only have access to that here. So the place where we need the status code is a different place than where we get access to the body. And that's the problem we face here. Essentially, we need to write some wrapping code here to make all of that work. We can say if we have an error, then I want to parse my body with JSON. That yields a new promise, and now we have a promise chain in a promise chain, which is never such a great idea. But then here I have access to my error data, and now here I could throw my error and maybe utilize this extra error data we might be getting by the server. So let's now give that a try. If I reload and click fetch posts again, and now you see a different problem. Now we throw the error basically in that nested promise chain, so the outer promise chain doesn't have an error, and hence we again think everything is fine and we try to list our posts, and that of course breaks. So throwing the error here in the nested promise chain is also not an option. We need to throw it outside of there, but there we don't have access to the error data. So how can we solve that? Well, we can move that back in there and simply return that inner promise chain so that it is basically merged into the outer promise chain, or now connected to the outer promise chain. And now with that, if I reload and I click fetch posts, now we have the proper error propagation and we have access to the error data. So it's possible we can solve this, but of course that's not the most beautiful error handling code you ever saw. It is what it is, however, with the Fetch API, and this is how you can use the Fetch API and implement proper error handling with access to the response body at the same time. Now with that, if I go down here and I re-add try catch here, let's see if that all works. If we add this block again, reload, click fetch posts, now I get something went wrong here as an error alert, and we don't try to use the invalid data. If I, on the other hand, fix this link again, and then I reload, then fetching works again. So that's the Fetch API and how we can handle errors there. So now we had a look at XML HTTP request and the Fetch API. Both allow us to send requests. The Fetch API is more modern and not supported in older browsers. A big plus is that it's generally easy to use and uses promises out of the box. A minus is that error handling can be clunky. Of course, not the end of the world, but not the most beautiful approach. Now, arguably, that's also not that beautiful, but if you hide it behind some custom function, it might be fine and might be a bit more straightforward to understand. In the end, however, you can also hide this behind a custom function and you're probably fine again. It's up to you which approach you use. Both are fine to be used. And actually, another alternative which you have is that you use a third-party library, something we haven't really touched on yet, which might wrap this, so the XML HTTP request, or this Fetch API approach, and gives you a nicer API to work with where you don't have to care about how it's implemented internally. And that's actually something we'll have a look at in the third-party libraries module, which comes right after this one. But it's important to understand how to implement this natively, and often the Fetch API is great because it's easy to use, quick to get started, and uses promises out of the box. But also be aware that XML HTTP request has better support for older browsers out of the box, and in some places regarding error handling specifically might be more straightforward. Now, besides different ways of sending HTTP requests, we also can send different data. In theory, at least. It always depends on the server and the URL you're sending this to, which kind of data the server accepts. For example, our dummy server here really only works with JSON data. When we, for example, send the data to fake create a post, then we have to add JSON data there. It does not accept any other data. But of course, you might be working with different APIs in your projects, and there different data might be accepted as well. Now, you can send files, you can send binary data and add this as a body here. So you could add a pointer at a file, which a user picked in a file picker, for example. Or another very popular data format, you could add form data. Now, let's see what form data is. And for that, let's go to create post. Here, I create my post object, add this to send HTTP request, and in there, we basically convert this to JSON and add it to the request. Now, we can also add form data instead. Now, again, this API does not support it, but other APIs might, and hence I want to show to you how that would work. For that here, in create post, let's say we can create form data by creating a new constant, fd for form data, name is up to you, by calling new form data. That's a constructor function built into JavaScript or built into the browser provided in JavaScript. Now, form data builds a new object to which you can add key value pairs, so a bit like a JavaScript object like this, but internally, or when it's sent over the wire, it will be sent in a different way than JSON data. It's not JSON format, it has a different format, as you will see. Now, to form data, you can append new entries with the append method, and there every entry has a key and a value. So for example, we could add a title and then pass on the title we're getting here as a value for this key. Same is true for the body. Here we could pass in our content value and also our user ID. Append user ID, user ID. Now we would have prepared such a form data object. Now let's add FD here, form data, to this request. So let's pass in this as a third argument. And inside of send HTTP request, we now have to change the request a little bit. I'll comment out the headers because I no longer want to tell the server that I'm sending JSON data, because I'm not. And instead set body not equal to the stringified data version, but just to data, which should already be form data. And for form data, the fetch API will automatically see that it's form data and automatically send the right headers. So if we set this and we reload, let's try it out. Let's create a new post with form data and click add. Now, if we inspect the network tab, we see the API is quite forgiving. It still reports a success because it really doesn't care about the data we send in the end because it's a fake API. But if we scroll down in the headers, we see we added different data. It's indeed form data, and that's a special type of data which is added to the outgoing request. If we have a look at the other headers, we see that their content type was automatically set to this value, which was automatically derived by the browser in the end. Now, the advantage of form data is that, for one, you might find it more structured to build your data like this. B, a second great thing about it is that you can easily add files. If you append some file, you can have any identifier you want here. You could point at a file here, for example, picked in a file input, and then as a third argument even provide a file name like photo.png, which the server can use. So you can easily send a mixture of text content, text key value pairs, and files to the server, which can be really convenient depending on what you build. And a third advantage is you can also use this to automatically parse a form. And that's actually what I also want to show you here. Let's say we don't manually add title and body, but instead we want to utilize the form fields which we already have here. Essentially what we want to do here is we want to replicate the default behavior the browser would have if we wouldn't call prevent default upon a submission. When we call that, we make sure the browser doesn't collect the form data and send it to a server. Now, we still want to make sure that the browser doesn't collect and send, but we then manually want to collect it in the same way the browser would. And for that, you just have to pass a pointer to your form element to form data, so to the constructor. And form here really is just this pointer I select up there. It points at the form element in the document, and if we pass that to form data, JavaScript will try to automatically collect all the data from the form. Now, for it to succeed though, you need to make sure that your inputs have a name attribute, title, and here maybe content. Or actually body, because the API wants a field named body. The name attribute is important, otherwise form data is not able to identify these inputs and get the data out of there and store it correctly in the form data. Now you can then still append extra data which might not be included in the form, like the user ID here. And with all of that, let's give it a try. Let's reload. New post. Does this work? And let's click add here. And if we now inspect this outgoing request and we scroll down, we see this was still populated, but now automatically from the form. Now again, it's important to realize that not all APIs support form data. If an API wants JSON data, you can't use this, no matter how convenient you find it to be. But if you have an API endpoint, so a specific URL HTTP method combination that does support form data, you can use this approach. And therefore, form data, besides JSON, is also an important data structure you should be aware of when we're talking about sending data with HTTP requests from client-side JavaScript to a server. And that's it for this module and for HTTP requests. You learned about two alternatives and how HTTP requests in general work, why we might want to send such requests and how we do that. You learned how to add data, how to promisify XML HTTP request, how to handle errors, also with the fetch API, where this is a bit more tricky, and you learned about different data structures, JSON and form data. Now, as I mentioned, there is of course way more you can do with HTTP requests. It would be enough content for a separate course actually. The core parts were covered in this course though, pretty extensively actually. If you want to dive deeper, definitely check the resources attached to lectures in this module and also linked in the last lecture of this module. These resources will allow you to dive deeper into XML HTTP request and into the fetch API and learn about things like file upload and way more. With the content covered here, however, we already have a pretty good understanding of how that works and why we do that. In the next course module, we'll learn about third-party libraries, which will make certain tasks, like for example, sending HTTP requests, even more convenient.